Good morning, everyone. We're about to start the webinar soon. Let's just wait for the attendees to come in. They're beginning to come in. Welcome. Good morning, everyone. Good afternoon to those who are in the United States. And good day to whoever is not in the US or the Philippines. I can see more than 100 participants, and the numbers is still steadily increasing, so let's give them a few more minutes to come on board. All right, before we start the webinar, we just want to show to you some reminders. We have a question box, so if you have any questions, please use the Q&A box. We may not have any time to let any questions in live or answer any of them live because there's right now 120 participants. But please type in your questions in the box provided, and if you could please put your name and affiliation so that we can address you properly. There is info@uprdf.org. If you have a burning question that were not asked, please send your questions to that email and we will respond to you the soonest possible time. And of course, if you're having technical difficulties, please send a message to that email as well, or go to the chat room and send a small note to Nori so that we can help you. Thank you. Nori, please go ahead. Hello, I'm Dante Briones. I'm from the UP College of Engineering, Industrial Engineering Batch 82. I'm currently president of a solar energy company named Sasunbi. I'd like to welcome you all, ladies and gentlemen, fellow engineers and alumni of the UP College of Engineering, guests from the scientific and research community, HPC enthusiasts, friends. I am deeply honored to welcome you all to our webinar entitled High Impact R&D through High Performance Computing. This webinar is brought to you by the UP Engineering Research and Development Foundation Incorporated in collaboration with the UP Alumni Engineers and the UP College of Engineering. To start our program today, I would like to introduce to all of you the Dean of the UP College of Engineering, Professor Ferdinand Manigdeg. Professor Manigdeg is an ex officio trustee of the UP Engineering Foundation. He is a professor of mechanical engineering. He earned his BS Mechanical Engineering degree from the University of the Philippines in 1979 and his Master of Science degree from the University of Leeds, United Kingdom in 1981. Ladies and gentlemen, please welcome Dean Manigdeg.
Nori,
take it away, Dean.
I cannot share screen. Can you give me an access to the share screen, please?
You can go ahead.
Okay. All right. UPFI Chairman Alexi, President Ferdinand de la Cruz, honorable members of the Board of Trustees and general members, Executive Director Alfonso Tito Aliga, UPAE President Elmir de la Cruz, fellow alumni, faculty members, industry partners, ladies and gentlemen, a pleasant day for everyone. Tito requested me to provide a brief college background and a pitch to the very high-speed computer donation launch. For some of you who have seen this presentation, it should be a history lesson. But I'd like to present it anyway so that those who have not seen it will be able to get some information fresh from the college. The UP College of Engineering consists of 6 departments and 2 institutes. The National Graduate School of Engineering with the Department Institute graduate degree programs, and 3 college interdisciplinary graduate programs, and the National Engineering Center with its 5 constituent centers. We have 12 undergraduate and 21 graduate programs being offered by the college. I am also proud to for 2020, the college has produced 945 Bachelor of Science and 116 Masters of Science and PhD graduates. We have an excellent roster of 264 full-time and 89 part-time faculty members, 76 regular and 31 non-UP administrative staff, 46 research, extension, and professional staff, 60 utility personnel, 45 security personnel, and 50 personnel under job order. The college has 147 professorial chairs awards, of which 139 are supported by UPRDFI, and 25 teaching and research grants, of which 24 are supported by UPRDFI. However, we have 204 faculty ranked in the assistant to full professor levels, together with 60 instructors that are all qualified for awards and grants respectively. With the new round of promotions, we now have 16 instructors professors to present that the college has new Manology Mena and Professor Emeritus Guillermo Professor Emeriti. Our faculty members are also involved in various research and extension activities that are funded by the government, specifically the UST, DTI, BSP, CHED, DPWH, and other government institutions, UPD Liman, World Bank, and private funding institutions, including UPRDFI. Most of these research agenda are geared towards creating engineering solutions that benefit humanity, particularly the poor and underprivileged Filipinos. The college is always at the forefront of sustainable progress to genuinely serve the people. At the early stages of the quarantine lockdown in March, the college COVID-19 response team was formed. It was mandated to help facilitate the creation and implementation of specialized projects that provided engineering solutions related to the needs of the community during the pandemic. Thanks to the donations of donors and the brilliant minds of our faculty, a total of 14 projects were approved for implementation. 3D printing solution for frontliners produced 3,000 face shields and were distributed to 6 provinces and 54 hospitals. The prototype adult ventilator project aimed to create a cost-effective alternative to commercially available ones. The tracking high-risk individuals has 2 platforms. The TRAMS aims to help the government in the proper allocation of medical resources via online system, and Contra Plus, a contact tracing mobile application that uses technologies such as GPS and Bluetooth to identify the contact history of a person, both offered to hospitals and the Quezon City government. Project 4 is the disinfection and decontamination through plasma cleaning, which developed a plasma system for cleaning and disinfecting surfaces. Project 5 is the disinfection of PPE via UV light. 3 prototypes were initially designed and fabricated to disinfect coveralls and laboratory gowns used in COVID-19 hospital wards. 2 units were turned over to the Philippine General Hospital, the University Health Service, DOH Region 1 Medical Center, the UP Engineering Library, 1 unit each to East Avenue Medical Center, UP Manila Department of Dentistry, and to the college. Project 6 is the Chlorgen, on-site hypocrite disinfectant generation via brine water electrolysis. This project has designed and built an in-situ hypochlorite disinfectant system, which could be used in establishment and in local government units requiring constant disinfection. Project 7 is the design and prototyping of a powered air purifying respirator. Two separate designs were prototyped and now in the final stage of testing. Project 8 is the revitalization of non-functioning UP-PGH ventilator system. This project assessed 9 non-functioning ventilators at UP-PGH. Project 9 is the identification of potential drug candidates for the SARS-CoV-2 using structure-based drug discovery. It aims to identify 10 natural and 10 synthetic possible drug candidates against SARS-CoV-2 through the application of computational models, big data processing, and machine learning. Project 10 is the toolkit quick estimation of COVID-19 infectives. This project features 2 analysis tools that are made available to our local government units and was offered to the Quezon City government. Project 11 is another prototype adult ventilator led by an alumnus of the UP Department of Mechanical Engineering. Project 12 is the Integrated Emergency Healthcare System. It is an integrated personnel, material, and information system for managing critical hospital operations in an emergency setting. Project 13 is the UP Supply Chain COVID-19 Response. This project is a collaboration of different government agencies in the collection and storage of data into a common resource pool addressing the supply chain issues of food and essential goods brought by the pandemic. Project 14 is the Bike Share Program. The project existing fleet of bicycles were offered as a temporary mode of transportation to medical frontliners that were disadvantaged by the suspension of public transportation. The project lent out 92 bicycles to several hospitals in Metro Manila. These projects were initially offered to the public for financial support through cash donations. Indeed, the college is immensely grateful and overwhelmed by the show of support of our generous donors and benefactors. Similarly, the college is greatly indebted to the UPRDFI and UPAE for their assistance in accepting and disbursing donations. Projects 13 and 14 were fully funded, while Project 9 was partly funded by UP Diliman. We are happy to report that 8 projects are already completed, while 6 projects are on its final stages of testing. The college also tapped the generous hearts of our faculty members and the public to support affected no work, no pay employees, security personnel, janitors, and personnel under job orders. The donation drive was able to collect a modest amount and was distributed to the beneficiaries. Also, a 3,000 incentive award from the college and NEC for all its regular employees, research, extension, professional, and administrative staff is currently being processed for distribution. It is an unfortunate incident that one of the Northcom Security Agency employee who is stationed to the UP College of Engineering and to other buildings of UP recently succumbed to stroke and passed away. We appealed for support from our faculty members and staff to give financial aid to the family that he left behind. As all of us already know, the mode of delivery of university courses has been altered due to the COVID-19 pandemic. Currently, face-to-face teaching will be reduced and a huge portion of courses will be delivered online. Students are now confronted with the reality that their education will rely heavily on having access to a computer. The UP College of Engineering conducted a survey of its students regarding the needed assistance in anticipation of the transfer to remote hybrid learning. The college launched a laptop donation drive for our students. In this program, a donor can donate a pre-lab laptop computer, new computer, or cash. The business model for this drive is that either a student can rent to own a laptop or borrow a laptop from the engineering library. When I became dean last September, one of my visions for the UP College of Engineering is to transform and upgrade the standard of learning to what is called Education 4.0, which is aligned with the so-called Fourth Industrial Revolution, where artificial intelligence, robotics, big data, and the Internet of Things are the dominant features. Though it can be that it may take some time for these technologies to take hold in industries, this reality is inevitable, and it would be better to prepare the college now than the race for later. Education 4.0 ensures a higher level of competency for our students, gives them a competitive advantage upon graduation, and levels the playing field against graduates of other universities, both local and foreign. But this movement towards bringing Education 4.0 to the college will not be an easy task. It requires transforming teaching methodologies, reimagining examination and assessments, advancing adaptive learning, and installing the proper digital infrastructure. The establishment of a high-performance computing laboratory is especially crucial, as it will allow for advanced simulations by our undergraduates and graduate students. It will enable advanced research by our faculty and provide access to computing research laboratories, local and abroad. Though recent events surrounding the coronavirus pandemic led to the disruption of our students' learning, this unfavorable circumstance also strengthened our resolve to move the college forward to Education 4.0. Thus, as a first step, we are launching what we call the Very High-Speed Computer Donation Drive. With this fund drive, we aim to raise about $350,000 US, which is roughly equal to 17 million pesos. The money will allow us to purchase high-performance computers that will serve as the backbone of our high-speed computing laboratory. We have requested for help from the Department of Science and Technology through its Secretary, Honorable Fortunato de la Peña, and Undersecretary Rowena Guevara, and have committed to helping us in this endeavor for 24 million pesos for additional nodes, software, training, and infrastructure. But we still need plenty of assistance, hence we come knocking at your doors. Your donation to this drive will be of tremendous help, and any amount will be most appreciated by a great core college. I am very thankful for the first two alumni who donated each 1 million pesos and another two alumni who donated 2,500 US$ each for this project. It would be unrealistic to assume that none of you have been financially affected by the pandemic. Everyone has been shaken by it. Thus, I know it is not easy to continue opening your wallets to charity. Probably you have contributed to our FAST campaigns and to many other COVID-19 donation drives, and donor fatigue has set in. But if quarantine rules have forced us to close the physical doors of our homes, let us still keep our hearts open. Indeed, you may think of your contribution to this drive as an investment in your family, your kids or grandkids. Could be the beneficiary of this equipment if they enter the UP College of Engineering. It is an investment in your business, as future graduates can be your employees who will become contributors to your sustained success. This computing laboratory can also be used for future industry research collaboration with the college to aid your operations and bring significant benefits. In closing, I feel that everyone has an innate desire to make a difference, even in the life of just one person. In these drives, you are earnestly called to make a permanent difference in the lives of not just one, but multitudes. You are called to leave a legacy that will benefit generations of entering students at UP. I humbly encourage you, please do not miss this opportunity para sa sambayanang Pilipino. Mabuhay ang Kolehiyo ng Inhenyera Mabuhay tayong lahat at maraming salamat po.
Thank you very much, Dean Manigdek, for giving us an update of the great work that's being done by our faculty members and our students and the UP College of Engineering ecosystem in general. We would like to honor some of these early donors, and to do that, I'd like to call on Engineer Victor Villagrasia, or Vic. Vic is a mechanical engineering graduate of UP in 1975. He is currently Senior Vice President at UBS Wealth Management based in San Francisco. Vic and his wife, Carol, sponsored the professorial chair and thesis support grants in the college. He is active in his fundraising as trustee of UP Engineering R&D Foundation and is the director of the Friends of UP Foundation in the USA. Welcome, Vic.
Thank you very much, Dante, and thank you all for joining this webinar. This is an important event for UP and the UP College of Engineering. First, let me acknowledge the presence of Dr. Matt Sherborne of UC Berkeley and Alison Aravelo, the two individuals who made us all aware of the talents of UP College of Engineering faculty and students in computational analysis. Last year, at the General Reunion of UP Alumni Association in San Francisco, Chato Calderon, the past president of UP, Erd Fee, mentioned to me that Allison was seeking UPAA in America to help the College of Engineering acquire a high-speed computer. I spoke to Allison about it, who then introduced me to Dr. Matt Sherborne. Matt and Allison gracefully accepted my invitation to meet in San Francisco, who then explained to me in layman's language what a computer cluster is and how it can exponentially speed up mathematical manipulations. Matt convinced me that it will increase by leaps and bounds the capability of UP to speed up the results of research coming from students and faculties, and will graduate students who are comfortable in computational analysis that will contribute to the technological capability of Philippine industries. Well, immediately after that meeting, I sounded out the idea to two friends about the project. I was encouraged by their interest. I sent to both the PowerPoint materials that Matt and Allison created. Of course, it's not the only students who need the computing power. During my subsequent trips to the Philippines last year, Chato and I had conversations with Dean Manigdeg, Dr. Noga, and other faculty members in computer science, who synchronously has been conceptualizing having and using a high-speed computer. And early this year, with the help of Polly Cortez, the vice chairman of Friends of UP Foundation in America, or PUPA for short, arranged a meeting with President Danny Concepcion for me and another member of UPAA, Mika Abao. President Concepcion browsed through the PowerPoint presentation of Dr. Denoga and was convinced that we should pursue the project and suggested that PUPA could help in providing some funds. There were many other UP alumni who provided encouragement. Just to name a few, Sonia Delen of UPAA, Gabi Moraleda, Simeon Godinez, and other members of PUPA, as well as members of UPAA. Oh, by the way, the two friends I immediately got in touch with after my meeting with Matt and Allison were so convinced that they generously put money on the table. So they are the first donors for the acquisition of the computers. They are Mr. Joel Bano and Mr. Herbert Lee. And just a few days ago, upon hearing of the initiative, another UP alum, Mr. Danny Reyes, immediately sent in his monetary support to the project. Thank you, Danny. We will give Joe and Danny a chance to say a few words later. Herbert is unable to join us, but Mrs. Marie Lee sent a note in behalf of Herbert. I shall read those to you later. With that, let me turn you back to Dante.
Thank you very much, Vic. And so now we move on to letting us know more about the details of the High Performance Computing Lab. To do that, may I call on Engineer Rafael Nestor V. Mandaring, or Chicho to most of us. He is a BS Electrical Engineering graduate of UP in 1978. He used to be a senior executive of IMI Electronics, the electronics company majority controlled by Ayala Corporation and one of the leading electronic companies of the world. He was the president of ROM LSI Design Philippines, and at one point was the chairman of the Department of Electrical Engineering in UP. He is an electronics engineering practitioner, a professorial lecturer in UP, and currently serves as the secretary of the UP Engineering R&D Foundation. Tito and his wife Lisa also established a professorial chair in 2009. He will also honor our early donors from the Philippines. Go ahead, Tito.
Thank you very much, Dante, for that very flattering introduction. Before anything else, I'd like to give you an idea of what this initiative of the UP College of Engineering is all about. High-performance computing is the ability to process vast amounts of data and perform complex calculations at very high speeds. If a normal desktop computer can perform, say, 1 billion operations per second, a high-performance computer can perform millions of times faster. So problems that would have taken a desktop PC weeks or even months to solve can be solved in a matter of minutes. Unfortunately, these types of problems are becoming quite common in this world where everything is increasingly becoming interconnected, where there is need to deal with vast amounts of data, and where machine learning and artificial intelligence are changing the way things are being done. In this webinar, you are going to get a glimpse of some of these problems in the talks of 3 of our distinguished researchers. And it will be apparent to you how much more the UP College of Engineering would be able to contribute to society with a high-performance computing facility. We at the UP ARDFI, together with the UP College of Engineering community, are targeting to establish a high-performance computing lab consisting of roughly 32 nodes, each node containing up to 32 processor cores. Our target is to raise 20 million. Dean mentioned earlier amount of 17 million that is going to cover the hardware costs. But we decided to up the ante by 3 million so that we can cover some of the maintenance costs for at least the first 5 years. UP has committed to support the facility with 3.4 million in software costs per year, in addition to the cost of utilities and of course the facilitated space. At this point, I'd like to acknowledge the first local donor to this initiative. If you are from my generation, you would associate Gus Lagman with information technology, although at that time it was called electronic data processing. It may therefore come as a surprise that Gus is an alumnus of the UP College of Engineering, graduating mechanical engineering in 1961. Gus has a very distinguished career in IT, starting with IBM in 1962, onward to numerous companies which he either founded or headed, among which are Computer Associates Incorporated, ProTemps, Data Prep Systems, Vinta Systems, and System Standards Incorporated. He was the founding chairman of STI colleges. He played a vital role in the development of the IT industry in the Philippines, having been the president of the Southeast Asia Regional Computer Conference, the IT Foundation of the Philippines, the IT Association of the Philippines, and the Philippine Computer Society, where he was the first Hall of Fame awardee. If the 70s saw the start of a brain drain of IT professionals from the Philippines, Gus is partly to blame. Gus is also known for having once been a commissioner of the COMELEC, a position he deserved after many years of association with the National Movement for Free Elections. These past few years, Gus has been the president of the Automotive Association of the Philippines, which has been enjoying unprecedented growth under his watch. We thank Gus very much for his very substantial donation to this initiative. We will give Gus an opportunity to say a few words later in the program, as he's also going to be cited for his contribution to the college's professorial chair drive. With that, I'd like to turn you back to Dante.
Thank you very much, Chicho. We will get some word from our honorees later after the presentation. We now go to the main purpose of this web conference. We now get to peek into what high-performance computing can do. We have lined up for you 3 brilliant UP College of Engineering scientists and professors to this end. To start with, let me introduce to you a recently conferred Professor Emeritus of the UP College of Engineering, Dr. Guillermo Tabios III. Dr. Glenn is a professor of the Institute of Civil Engineering and Research Fellow of the National Hydraulic Research Center at the University of the Philippines. He teaches and conducts research in stochastic and computational hydrology and hydraulics, as well as water resource systems engineering. He got his PhD in civil engineering from Colorado State University in the USA in 1984. Prior to joining UP, he was a research associate of the Hydrology and Water Resources Program of the Department of Civil Engineering of Colorado State University in 1985 to 87, and was a research faculty of the Hydraulic and Coastal Engineering Group of the Civil Engineering Department at the University of California in Berkeley. He is an academician of the National Academy of Science and Technology of the Philippines and was a chairman at one point of the Department of Civil Engineering in UP. He is also a director of the NHRC and a member of the board of NWRB and chairperson of the Regional Steering Committee of the UNESCO IHP in the Asia Pacific region from 2015 and 2017. Ladies and gentlemen, let's all welcome Dr. Guillermo Tabios III.
Thank you very much, Dante, for the generous introduction. Let me first share my screen for my presentation. So I guess share. Okay. Slideshow. Yeah. So that's the title of my talk. So basically, high resolution flood modeling with two-dimensional model, but displayed in a 3D using LiDAR data. So just to paste the, give you a motivation by talk. How do I remove this one? So the motivation of this talk is to showcase a potential application of this high resolution flood modeling using the soon to be established high performance computing facility, which is the project of the UP College of Engineering with UP RDFI and the UP Engineering community. So basically this, I'd like to propose a methodology for high resolution flood modeling using two-dimensional shallow water equations based on finite volume method and display the flood results in an enhanced 3D flow visualization using LiDAR data. Of course, we can use LiDAR data for high resolution flood modeling by, say, if it's a 1 by 1 meter grid, you would discretize the modeled area into those 1 by 1 meter grids. But I think in the Philippines, we still don't have that computing power to be able to conduct such flood simulation. So just an aside here, I think LiDAR data should be made more available to researchers to be able to fully utilize the data, especially for flood inundation studies and to develop flood hazard maps or flood susceptibility maps. So let me show you some examples, the current sort of the state of the art of using the LiDAR data and especially in flood modeling. So this is a report from the DREAM project. I think it's a project of Project Noga, which shows you a simulation flood inundation study of the Cagayan de Oro River Basin, which in which they use this hydrologic engineering center hydrologic modeling system, HMS, for the watershed hydrology, and then use Flow 2D. It's commercially available at two-dimensional shallow water equations model, and they use 10 by 10 meter grids and based on LiDAR data for flood simulation. So you can see how not quite high resolution when they display it, but even with flow 2D, it's a two-dimensional model, maybe not with a 10 by 10 grids, maybe they have limitation in computing power. This is another application, just to give you an idea, in flood modeling, flood inundation mapping in the same system using HEC river analysis system. They use a one-dimensional steady flow, but this is like a pseudo two-dimensional, because you have a network of channels, and then the results are exported to what we call the ArcGIS of the HEC program, and then using LiDAR data again, they were able to, they create the hydraulic model geometry. So LiDAR data is used to create the hydraulic model geometry, and then the display using LiDAR data. I also did my own, and then this is where I'm coming from. That's why I'm showing you this flood inundation studies. I also did some flood modeling in Cagayan River Basin. I used for the hydrology, Sacramento soil moisture accounting, and then this was written in Fortran as opposed to just getting a model, and then two-dimensional shallow water equations with finite volume method. So I kind of emphasize the explicit scheme because this may be the best way to do high-speed computing. And then, of course, we didn't have LiDAR data, so we use SRTM, which is available from NASA websites, and then also DPW river cross-section. So the way I display, for instance, I didn't like to interpolate and display it in a continuous, like spatially interpolated data, and then it kind of aliases or smoothens the flood levels, so you don't really see by per element or by grid the flood inundation levels. So I'll go back to that later on, why I display it that way. But then, of course, if you are going to use a LiDAR data for 3D display, this will be much more finer. So let me go to just the shallow equations. If you are modeling, flood modeling for an urban area where you have buildings or obstructions, you don't use the regular shallow water equations. Maybe I'll just run through quickly, but what I wanted to point out here is that if you have the continuity and momentum equations in the x and y direction, the key parameter in this model is the Manning's roughness, only one. So if you have, let's say, 10,000 grids, then maybe you'll have 10,000 Manning's roughness specified for each grid. But if you have obstructions, this is not able to properly do flood modeling, especially in urban areas. And that's what we call, we introduce our artificial porosity, which is in the continuity equation, we call it storage conveyance, storage porosity, while in the momentum equations, we call it the conveyance porosity. So the difference between the shallow water equations without the porosity and then with porosity are this highlighted in some blue things. So I just want to show you that there are now 4 sets of parameters per grid. So instead of only one, you'll have 4. So that poses, of course, a problem when you do model calibration or model parameter estimation. So let me jump now. If you apply this model, this is what you'll see. If you use high resolution grids, fine grids, this is what you get. So this, let's say, the base simulation run. This is what the water depths you'll get in. Maybe this building and so on. If you use coarse grid, this is what you'll get. But if you have a porosity, artificial porosity parameter, you'll get the water depths closer to the fine grid. And the reason why I keep on mentioning why not use the LiDAR data on a 1x1 meter grid, because it's going to take so much computational time. Now the velocities, if you look at the velocities, this is what you'll get with the base case, which is the fine grid, coarse grid, this is what you get, but with porosity, that's what you get. So definitely much better if you introduce those porosity terms. This is another application for flood inundation in a channel with spur dikes. So the water depths again, this one, the fine grid, coarse grid without porosity parameters, while you have this one, the velocity is that one. So you can see why you need that porosity parameter, but then you need to define so much more parameters. So why use the finite volume method? Just want to show you the advantage of this one. Of course, it's unstructured grid as opposed to finite element, finite difference with orthogonal structured grids. The discretization approach integral, maybe I'll not go through that, but you can read through that. But as far as high-speed computing is concerned, the finite volume, it's much more better use in an explicit scheme. So basically the idea is that if you have a modeled area discretized into, say, 250,000 grids, like for example, maybe the Pampanga River Delta, Pampanga River Basin Delta, maybe it's about 3,000 square kilometers. So if you discretize into 1x1 grids, that's going to be 3,000 million grids. That's so many. But anyway, if you have 250,000 grids, and if you have a 1,000 core computer cluster, then maybe you can divide and you do vector processing or parallel processing. Then you divide the area into 250 sub-areas with 1,000 grids each. Then you can do that per area, do it simultaneous processing every computational time step. So you gain a lot. Instead of a serial processing, you have parallel processing for each sub-area. So that's the advantage if you use this one. The other thing with the finite volume, it's based on that integral formulation where the discretization is from the sides of the, so you call it fluxes. You can use it for different kinds of flow conditions, sub, super, critical. You can even have shock waves, which is designed to capture all these what you call gradually varied flows or rapidly varying flows, smooth or discontinuous flows. So just want to show you the feature. But going back now to the flood modeling I was proposing with the 3D flow visualization. So you still do a 2D hydraulic modeling, and then maybe coarse grids, 10 by 10 meter grids, or even 20 by 20. Then you get these results, just like what I did. This is a close-up of the grid system here. And then for that particular area, this is the close-up. And this for this particular area, that's the close-up. If you're then going to do the LiDAR data 1x1, given the total storage or stored water, computed volume of water in this area, you divide it by the number of grids, and then you say, given the total volume divided by 0.1 meter depths times 1x1 grid. So basically, you're going to put in delta incremental volume of 0.1 cubic meters, put it in the 1x1 cell. So this is what you'll get. Maybe in the beginning, you have only 2 areas that you have these 2 cells or 3 cells that will be, you put in delta V, next step, you have more, and so on, until you exhaust all the total volume. So if you do this every time step, you can then create a video with this very high resolution, nice flood inundation flow visualization. So that's basically how the flow visualization. So again, I'd like to go back with the model calibration because there are so many parameters. Just for example, in the Cagayan River Basin, in the way the mesh area around the city, I modeled that, which is a total area of 15 square kilometers. So total number of grids, 6,000. So you can imagine that with that, more or less each grid is about 2,500 square meters or average length of 50 meters. So it's 50 by 50 as opposed to 30 by 30 or 10 by 10 done by the second example I gave, which is from Xavier University, and then from the Dream Project 10 by 10. But in any case, just to show this one, if you have a total 4 parameters times 6,000 grids, that will be 24,000 parameters that you need to estimate. You cannot do that manually. It's going to take you forever to calibrate your model. So the best way will be to embed your shallow water equation model in an optimization model where you have a constraint optimization with, say, a least squares objective function of the observed and computed velocities and water depths, depending where you are, if you have observed data at several points in the system. So with that, I think this is my final slide. So just to give you an illustrative computer requirement for the Cagayan de Oro River flood modeling. So definitely we need a high-speed computer or high-performance computing facility here. So with 6,092 grids, and then for 3,600 computational steps, I did the computations using my laptop, which is a Core i7 7th generation processor. It has a rated speed of 40 gigaflops. That means 1 billion floating point operations per second. Thus, in my case, I estimated that for one grid, one time step or one computational step, it will take 1,800 floating point operations. So that's so for a high resolution model geometry, which is reduced to size of 10 by 10, the number of grids will be 30,000. That's 6,000 times 5, because I have 50 by 50 for the 15 square kilometer modeled area. So if you calibrate the model using optimization, with 4 parameters, that's going to be 121,000 parameters to be estimated. So with, say, using some nonlinear optimization technique, constrain, because you constrain the parameters, the Manning's N, the storage porosities, and the conveyance porosities, maybe you will need 121 times 5 function evaluations. That means, if you remember, the previous slide shows you the optimization embeds the soil, the shallow water equation model. You would need so many computations. And if I do some computation for just one storm, you calibrate your model, 36-hour storm, which is like the Sendong case, it will be using 3,000 computational time steps per hour. That's 1 second time step for numerical stability. It will require 4,384 petaflops. That's 4,384 mega gigaflops floating operations for all that model calibration. So if I use my computer, my laptop, which is rated at 40 gigaflops, this will require 1,268 days. So that's roughly about, 3 years, 3.5 years. Of course, if I have this 1,000 core HPC computer cluster, maybe divided by 1,000, maybe it takes only 1.2 days. So that's a big difference. And then assuming that you already calibrate your model for a 30-day simulation and a 3D flow visualization. So when you calibrate, you don't need the flow visualization. With LiDAR data, it's displayed every 1 second, so you can get a nice movie. It takes about 3.49 days. So about 3.5 days. If it's a single core computer, but only about 5 minutes for a 1,000 core. So definitely I don't need to convince you why we need this kind of computing facility. And apparently we haven't been able to do this because we don't have access to these very high-speed computers. Thank you very much. That ends my talk. So,
Thank you very much, Dr. Tabios. Very relevant indeed, especially for a country that is so flood prone. And with all the climate change effects in this country, we hope to support you in this undertaking. We actually have a couple of questions directed to you, which we will throw to you later. Our next scientist, professor, speaker, thank you very much, Dr. Tabios, is Dr. Gerald B. Kinay. He is an associate professor and the head of the structural engineering group of the Institute of Civil Engineering in UP. He serves as the faculty in charge for the DMCI Holmes Computational Laboratory and conducts research on computational earthquake engineering. So earlier we have floods. So with Dr. Kinay, we will have earthquakes. Engineering seismology and high performance computing. He was an assistant professor in Niigata University in Japan from 2012 to 2016, but came back home in the same year as part of the DOST Balik Scientist program. He has a PhD in civil engineering from the University of Tokyo. In 2012, was a research assistant in the same university, the Earthquake Research Institute, and he got his master's in civil engineering from the Tokyo Institute of Technology in 2009. And of course, he finished his BS Civil Engineering from the University of the Philippines in Diliman in 2005. Let us all welcome Dr. Gerald B. Kinay.
Okay, good morning to all. I'll just share my screen. Okay, I would like to start my presentation. But before that, I would like to introduce the past and present members of my team in the UPICE. The research work that I will be presenting today are outputs of our research projects with aid of high performance computing. Okay, so earthquakes are scary phenomena. So every time we feel it, we are caught by surprise. And every second of shaking seems to be very long. And we hope that the shaking will not get any stronger. As we can see in the figure on the left, many earthquakes have already occurred in the country and has covered almost a large part of the country. And some of these earthquakes, most of these earthquakes are small, but a few ones are large earthquakes. And just last year, a series of large earthquakes occurred in Cotabato that have caused considerable damages extending to nearby cities. And the UP College of Engineering, led by Dean Manigdeg, they sent engineers to assess some of the buildings there. And we know from the OST FIVOX, Fault Finder, and Hazard Hunter that there are many cities that are at risk of strong ground shaking. So there are many physical processes that can affect the severity of shaking in an area. Given the availability of sufficient data, such processes can be studied using numerical modeling. So our team is focused on developing tools for seismic response simulation. And our tools aim to model the fault process of wave propagation from the fault to the site, the response of the site where the city is. So this includes the city response. And within the city, there are buildings. So this will also include structure response analysis. And for each structure, there is a component analysis involved. Note that the overall process encompasses the geologic and engineering length scales. And the accuracy of our simulations are influenced by the mechanical properties, and geometric configurations at these scales. So, okay, so let's start with the fault to site analysis. Here, we aim to model the source process that are governed by the source mechanisms, and that modeling will result to body wave propagations propagating through layers of bedrocks going to the surface. So the important factors here are the parameters of the crust, the interface geometry of the layer interfaces, including the surface topography, the mechanical properties between layers and soft soil, the basin geometry. These are the important factors that are very difficult to analyze using the widely used empirical methods. But it's very straightforward if we will do numerical modeling. So in numerical modeling, we use the finite element method for this analysis. And these are examples, the figures on the right. This is for surface topography modeling, where we include the surface topography and also cross-layer interfaces. We use a mesh of tetrahedron and hexahedron elements with, of course, implementation of some computational techniques to reduce the computation cost, while computational memory requirement, while satisfying accuracy at the modeling the geometric conditions. And then we apply that to Metro Manila and the nearby region. So Metro Manila is somewhere here. We have the West Valley Fault running along this line. And then we have highly varying topography in Rizal area and the eastern part. The computational domain is 34.6 kilometers by 34.6 kilometers by 50 kilometers in depth. And we have a finest solution of 60 meters. And then we choose several points in Metro Manila, say one in Marikina, one in Manila, one in Pasay, one in Pateros, as for demonstration, because these points have different thickness of soft soil layers that we expect can affect the amplification of ground motion at the surface. So this is an example of one result, a scenario 7.2 along the West Valley Fault. So as you can see, the rupture starting from the upper part going down, that results to a complicated pattern of long period propagation, affected also by the substructure at the area. And another observation we can see is that along in this area with highly varying topography, the waves interact longer with these surface irregularities. So these are a good study for our students. And then we're looking at the points that we want to study. We created the soil columns with varying soil depths. And these varying soil depths and properties for these areas, as you can see in this animation, shows that they are not in phase when they move at the same time due to the difference in arrival times going to the surface of the seismic waves. In terms of computation, this scenario earthquake simulation is a 20 million unknown per time step problem computed using parallel computing in the USD ASTI core HPC in 7 hours. While this amplification simulation study is a 500,000 unknown per time step, so a smaller problem size. And for that, we used GPU computing, so 5,000 CUDA cores of the USD ASTI core HPC was used for this simulation. Okay, so let's move to city modeling. The challenge in city modeling is that we have so many buildings to model that vary in geometry, vary in material properties and vintage. but we don't have all the structural data information to construct the structural model. So what we did is we extracted feature data from GIS information. This GIS information are actually derived from satellite data. And we trained an artificial neural network to determine the number of columns, column locations, interfloor, floor-to-floor distance, and beam configurations. So what we get at the end are generated frame models like this. And the tool also is capable of imposing different loading cases depending on the scenario that we want. So combining all these generated frames, we can see the frames here in correct position and orientation. And performing the analysis, we get, for example, strategic results that very much can be compared with damage state. This figure shows that some buildings will respond significantly to the scenario earthquake loading, while some buildings will not. Now, if we can extract those buildings which have resulted to large drifts or some significant response, dynamic response, we can analyze them in this procedure where we integrate CAD and CAE. So we start from BIM representation or CAD models directly inputted to our software that meshes either with solid finite elements or line elements based on Euler-Bernoulli theory, and perform the usual analysis. But the application we are doing right now is on the design and analysis of dual systems. So dual systems are high-rise structures wherein the shear walls are used to control the lateral loading, to resist the lateral loading, while the frame will resist the gravity loading. And given some criteria for drifts, it's very difficult to get the optimized configuration of shear walls and frames. So this is a really iterative procedure, and our tool can generate a multi-resolution FEM model shown here with 800,000 elements in 10 minutes using single core of the UAST core HPC. So if you have like 1,000 core, then we can generate 1,000 multiple configurations, perform the analysis, and from there extract the most optimized model depending on the criteria that we set. And now we can focus on, say, the most stressed component in the structure. For example, this one is nonlinear modeling of a wide flange subjected to a axial loading. We can also specify other loading conditions. But for this case, we implemented higher order finite elements together with some hierarchical multi-resolution modeling to reduce the iterations in the solvers. And also we implemented shared memory parallel computing using OpenMP to run in the UAST core HPC. So what's the ongoing work? The ongoing work is to perform the dynamic analysis of the whole Metro Manila, as this one is a part of that. Approximately 1.4 million structures to solve, or 350 million unknowns per time step. The estimated computation cost will require 400 hours of runtime and 100 gigabytes of memory for a 40-second earthquake simulation. So why do we need to perform such a dynamic analysis of the whole Metro Manila? Because an earthquake such as the West Valley Fault earthquake will affect all the cities. And the outputs of this simulation can be used as input to intercity planning, such as transportation simulations, evacuation simulations, or positioning of early response equipment and personnel. We're also working on integration of BIM model, finite element analysis results, and utilization model, so that we can have a first-person view of say a particular structure. As you can see here, there is we can see the distribution of stress around the particular area that we are trying to assess. So this gives us probably an effective way to communicate risk to non-technical stakeholders. And also for those first responders assessing buildings, it's important that they're familiarized with not only the structure, but also the non-structural components, because there might be some areas in the building which has hazardous chemicals or dangerous non-structural components. We also work on dynamic analysis of infrastructure. The challenge here is the long computation time, because, for example, a very long stretch of this elevated structure, the long period component can result to phase difference within the length, along the length of the span, and this requires a longer simulation time because the long period waves travel very far. So for such a long structure, an active fault is very, very far from it is still a big contributor to possible damage. So I'd like to conclude with the availability of HP resources has supported our team's research objectives, focusing on simulating the various processes from the fault to the components. The availability of HPC resources, we can implement, test, and new numerical computing techniques to advance our research on hazard modeling, city and structural response analysis. It's important to note that HPC is just not computing with numbers. So from it, we can learn how to set the right comprehensive model to be used for our target application. It can harness creativity in how to address computationally costly operations, because we know we have very limited memory, limited computation time to run, and limited disk space. And being rooted in programming where errors are breakfast, it teaches patience, humility, and attention to detail. So I would like to acknowledge the UST Core HPC. Most of our large-scale jobs were run using this facility. The DMCI Homes Computational Laboratory is where we develop our codes and perform our small tests before we run them. The UST Fevox provide us with Earth models and earthquake data to compare our estimates. Computational Science and High Performance Computing Laboratory, Earthquake Research Institute, University of Tokyo, guiding us on what's new with the application of HPC on earthquake engineering. And of course, UP ERDFI for inviting us to present our research work in this webinar. Okay, so that's the end of my presentation. Thank you very much for listening.
Thank you very much, Dr. Kina. Truly an amazing presentation. We very much what Dr. Tavios presented. So we are delivering our promise to you, ladies and gentlemen, and you will be amazed again with the presentation of our next scientist, Dr. Gerald Josie de Noga. He is a professor of mechanical engineering of the College of Engineering and Associates Dean for Research and the holder of Fernando Serena Professorial Chair in Mechanical Engineering. He is the founder and head of the Machine Design Laboratory, Design and Manufacturing Center instrumentation, robotics and control laboratory, Emerson heating, ventilation, air conditioning, and refrigeration laboratory. His latest projects include prototyping of a diesel-electric parallel series hybrid vehicle for public transportation under the DOST-DOTC UP Triumvirate, and very relevantly, the development of powered air purifying respirators in the light of COVID-19. Happy, as he is known to us, is a Doctor of Philosophy in Energy Engineering, the valedictorian from the University of the Philippines in 2017. He got his master's degree in Mechatronics Engineering with high distinction from the University of New South Wales in Sydney, Australia, and his Bachelor of Science in Mechanical Engineering cum laude from the University of the Philippines in 1999. Very young scientist indeed. Ladies and gentlemen, let's all welcome Dr. Happy de Noga.
Thank you very much, Dante, for the kind introduction. I will just share my screen. Okay, so good morning, ladies and gentlemen. I would just like to highlight some studies on finite element analysis studies done on Philippine public transportation vehicles. Now, there are several of them, so rather than just focusing on just one study, I'll be highlighting several, but rather quite quickly. Okay. So starting with the first one in 2013, we at the UP Mechanical Engineering Machine Design Laboratory was asked to collaborate with MIRDC to do studies on public utility vehicles. We were able to help them by doing the 3D scanning of the tricycle sidecar and an entire Jeep from Sarao. This allowed us to reverse engineer and create a digital model of the structure of the vehicles. The model itself was actually quite big. It consumed almost 1 gigabyte of data for an STL file, but it was because the resolution of the file itself was of 1 millimeter compared to a 6 meter long jeepney. But that kind of detail was needed because we needed to analyze both the strength and the other properties of the vehicle. Now, this model would be used for a finite element analysis. Okay. The MIRDC wanted to analyze it for the strength and crashworthiness. Now, for the strength analysis, the team was led by Brian Clavecilias and his team from MIRDC and from colleagues from the LSU. Shown here are the stress graphs on the chassis of the tricycle and jeepney, indicating that it's color-coded on the right, the pictures on the right, going from blue to red, and you would notice that almost everything here is blue, indicating that the chassis prove, okay, both numerically and as we see in real life, that they could safely carry the passengers, okay, with normal loading. We are aware of that. However, a bigger issue was what would happen if the vehicle itself was subjected to collision. Would it keep the passengers safe? So the model was then used for another study with Ryan Clavecilias again in the team, but this time headed by Mr. Jason Rogelio from MIRDC and new faces from DLSU. And they used the same digital model that we started with, and did crash testing simulations. Now, traditionally, a crash worthiness test would be a very destructive process, meaning that it would require one vehicle for each test and then no more. This would be obviously very, very costly and would not allow any do-overs. With FEA analysis, things are done virtually. We scan it, digitize the models, and then put the tests in the software. It takes a while, but the tests can be run over and over with different parameters. So with this study, the use of LS-DYNA software was used, and impact analysis, transient impact analysis, could be formed on the digital models. The test parameters for this particular case there were three. One test was for a full frontal impact at 56 kilometers per hour. Another setup was for an oblique impact, slightly to the side, this time running at 40 kilometers per hour, still in the forward direction. And the third setup was where we had a side impact from another vehicle hitting the GP at 54 kilometers per hour. At that time, we did not have the computing resources to do that at UP. The digital model used in these studies was about 350,000 elements. Technically, that is still small, a small number for high-end transient studies. But even with that amount, the typical desktop, it would take weeks for that structural analysis to be done. Now, fortunately, the MIRDC had just acquired a 5.98 million 64-core supercomputer at that time, and were able to successfully do some tests using those 350,000 elements. So shown here are the results of that full frontal impact simulation, where the driver cabin, if you see, I don't know if you see my mouse moving, but if you see here that with the frontal impact, it is the driver cabin that actually gets crushed significantly compared to maybe the engine compartment or in very minimal collapsing in the rest of the structure. Okay, so this would lead to severe injury or death to the driver and the front passengers. Studies like this would allow us to pinpoint the safety and structural issues without the cost and logistics of physical impact tests. With high-performance computing, complex problems like this can be solved. Now, moving forward to something more the present scenario, we are faced with a health pandemic, and with our problem about public transportation, that we need public transportation to bring our people to their jobs, and to just boost the economy, we have to find a way to revive public transportation and still ensure the safety of our passengers. There are many proposals and schemes to physically isolate passengers by dividers on jeeps and buses and trains, as what you see here in the photos. You see the jeep with the actual dividers, and at the bottom, the physical distancing proposed by another organization, and another proposal for things to be done on buses. However, there are no real studies yet on how the air and virus-carrying aerosolized droplets will actually travel within the vehicle and among the passengers. So with the lead of Dr. Louis Angelo M. Danao, we are assembling a team including Dr. Arnold Elapano, Dean of the UP College of Engineering from UP Los Baños, and Dr. Ralph Gallegos from UP LB as well, and myself, to analyze the aerosol flow in the GP to optimize occupancy while minimizing the risk of COVID transmission. So this is a future project that we are hoping that we can do with the HPC, but so that we can have some benchmark numbers and see, and so that we can enlighten the public on what studies, on what the results of such studies can be. Shown here is actually a previous study and it is in connection with a request by the Move as One Coalition. We were approached by the Move as One Coalition to investigate, evaluate, and design active ventilation retrofits for Philippine public transportation. So hindi lang po na maglalagay ng dividers, but rather, what about looking into how the air conditioning is ported properly? So in this slide, there are two. Okay, there were several scenarios shown in the study, but in the study by Zhu Shengwei et al., there are two studies for where on the left is a simple is a typical configuration of the supply and the exhaust ports of an air conditioning system inside a bus. So the blue actually indicates the blue rectangle at the top left is where it is exhausted from the cabin. And on the other hand, the red round ports at the edges of the bus are the supply air, meaning the cold air coming into the cabin. And the figures actually show how the air goes from the supply ports coming from the red ports and go back to the blue exhaust. And it shows snippets of it in, for example, B, C, D, E, and F show that there are substantial mixing of air, meaning it goes from one passenger and will actually impinge on another passenger on its way to the exhaust, which is not really advisable. On the other hand, if, for example, if on the right figure, the figure on the right here is where the supply air, the cold air, is coming from the bottom and is sucked out from the top, the air will travel, but it travels in a more direct route and only affects the passenger or impinges that passenger exactly. It does not go back and forth along the longitude of the bus, but instead just goes from the floor to the top of the cabin, which minimizes the distribution of droplets within the cabin. Now, this is a very relevant issue because we are in a tropical country and we still prefer our air conditioning, but we have to maintain the safety of our passengers. So by analyzing flows like this, we can propose certain improvements in our public transportation. So this is a future study, and hopefully we can do this once we have more powerful computing facilities, such as the HPC proposed in this particular webinar. Thank you very much and good morning.
Thank you very much, Dr. Happy Dinoga. Well, there you go, folks. From floods to earthquakes to transportation safety, this is what it's all about. This is what the HPC is all about. So we now go to the Q&A portion of our webinar. And if you notice, our Q&A box has been very, very active, and our speakers have been very generous in answering your questions. But if we could please ask you to identify yourself so that if there are any questions that we are not able to answer, we could get back to you later. Our first question, I think, can be answered by the college dean or perhaps any of the scientists. It says, it's from Miss Julie Hudson. I believe she's calling in from the US. It says, she has three answers. The two other questions were answered by Dr. Tabius already, but this question is very relevant. So I'd like to broadcast this to you guys. It looks like the use of this facility is universal and for various provinces in the Philippines. Why will not the government fund this project? Although I know there's some collaboration with the DOST, maybe Dr. Dean Manegdeg can answer this question. What's going on with our collaboration with the government in relation to this project?
Thank you, Dante. We have written the DOST already, and initially they have approved 24 million. for this project, subject to availability or clearance of the funding because of the pandemic. So that's as of now the status of that fund. However, this is for complementary scheme. That's why we are initially really looking at for a private donations to start this, and hopefully when we have the funds or when it's available, then we can add some more nodes and training softwares and other infrastructure that is required by the project. Now the question is, can we do this nationwide? Of course, it can be done nationwide, but since this is a high-speed computer, it is geared towards more on research, practically geared toward the industry. So this is how we approach it.
Thank you, Dean. I feel like Dean Maligdeg is politely saying that we cannot wait for the government funding to get this going. It is very relevant, so we're calling on the kind hearts of our alumni and our industry leaders to please help us move forward, because the government is very busy addressing many other things in the light of COVID. Thank you very much, Dean. The next question is this. We have heard what the great things are that can be done by the HPC in relation to flood control, in relation to earthquakes, and in relation to transportation safety. The question is, what's going to happen if we don't have this? What's the downside? If we don't have this, what's going to happen to us? Maybe I should throw the questions to our researchers and our scientists. What's going to happen to us if we don't have it? Dr. Happy?
If I may answer that question, Sir Dante, the problem we see that there are a lot of potential with high performance computing, but there is actually a bigger problem if we don't, okay? Because there are so many problems that need to be addressed, and we do not have the facilities to do that. People have been approaching us to solve certain problems, and when they ask us, and if we know that it will take, for example, 4 months to run a certain computation on certain desktops, I will either have to wait, meaning it's a very delayed delivery of solution, which is not acceptable in many cases, especially for industry. So we might be needed to do compromising shortcuts, meaning there are potential losses in accuracy and precision, and therefore we may not actually provide a non-definitive answer. And in the worst case, if the problem is really that time-consuming, we simply abandon the problem, and the problem is not addressed.
Very profound, Dr. Dinoga. So I hope we can forward this. Dr. Kinay, Dr. Tabios, please go ahead.
Yes, I would say that, if we don't have the facility at the college, let's just talk about the College of Engineering. It wouldn't spur research as far as students are concerned to do large-scale computations or, big scale, like for example, in flooding. If you don't have this kind of computing facility, you don't have anything in terms of maybe solving flooding in one stretch of the river instead of the entire Metro Manila or the flatlands of Metro Manila, because you need a lot of computing power. Now, maybe some of us, way back in the 70s or 80s, when you were in college at UP Diliman, I was in Los Baños, we have the IBM 370. It was made available to students. Without this computing facility, imagine nobody can think about doing large-scale computation. You'll just have calculators or this adding machine. How could you think about large-scale computing? So that's, I think, the difference. It will spur innovative, large-scale computing researches, which I think, like even I always mention that in flood modeling. The shallow water equations that I was showing, they were developed in the late 1800s. Reynolds equation, the Navier-Stokes equation, way back then, but nobody was able to use it until maybe in the 80s or 90s when computing became available. Can you imagine that? So you have a lot of these physical models, mathematical models have been available way back then. But only now we are able to think large-scale applications because we have a lot of computing power. Thank you.
Thank you, Dr. Tabios. You have anything to say, Dr. Kinay?
Yes, I would like to answer the question in two viewpoints. First is student learning. In structural engineering, usually we are accustomed to using softwares in our analysis. And usually softwares, they will give you values of, say, stresses and such. And after some time, these softwares get too complicated. It's very difficult to track what's happening inside. That's why my research team is focused on developing these tools, their own tools, so that they will be able to pinpoint on which particular part of the computation there might be some approximations. Now, so high performance computing is important, especially if, say, I'm analyzing as steel column beam connections, and I would like to know stress concentrations. Of course, commercial software will give you this answer, but how would student know how to refine the meshes around these areas? This will incur large computation costs, and I think the availability of HPC is very important in this case. Another is on the research on earthquake engineering. There's still so many unknown parameters, known parameters, but the accuracy of these models are very low. And I would like to connect that to one of the questions by Sir Domingo. If it's possible that earthquake hazard mapping of very high probability of exceedance can be achieved given this given assistance of this physics-based modeling. This research on physics-based modeling for earthquake mitigation will have to uncover so many research gaps or knowledge gaps on this, specifically on the substructure. We have a substructure of, say, Metro Manila and not of other cities. And even in Metro Manila, we have only a very coarse model of the underground, bedrock and the several layers. Identifying these knowledge gaps, this will, say, motivate other researchers to work on the subjects. These are working on this lies on another field, seismology, engineering seismology, and these things. So this HPC will be important in uncovering these knowledge gaps. And also what I've shown here are mostly deterministic simulations. And there are so many parameters here that are inherently random, and they will require stochastic analysis. And one simulation is already very large in computing time. And to do a stochastic analysis, a Monte Carlo simulation and such, and then you'll have to do, say, thousands of simulations. So I think HPC is important for probabilistic analysis and reliability analysis of structures. That's all.
Thank you, Dr. Kinay. I have an interesting question for Dr. Tabios regarding floods. I guess this is so interesting to everybody because there's hardly any other place, any major urban center in the Philippines that is not a victim of flooding. What can we do to support the LGUs so that they can have risk mitigation plans to make sure they can minimize the ill effects of flooding? Dr. Tabios.
The available, I think I showed some examples. The available flood hazard maps or susceptibility maps that we give out to the LGUs, I think they are very low resolution. You cannot use them for real comprehensive land use planning, which they do that and every 5 years or so. the reason is, if you display it like the way it was shown in the example, where you alias by interpolating the flood results, or, if it's a building, if they go to their community, they say, oh, there's a building here. How can we get flooded? Where do we go? And so on. So you really need a high resolution flood hazard map so they can make decisions and then incorporate in their land use plans. So definitely, I think the value of having for flood disaster risk management, it costs lives, it costs damage to properties and so on. So definitely, if you provide the LGUs with high resolution maps, I think they will be more confident in using them and be able to pinpoint, like for example, in flood evacuation schemes, where do you really move the people? What will be the escape routes and so on? If you don't provide these kinds of maps, they wouldn't know that it becomes flooded here or there at this elevation, at that time, and so on. So I think there's value to the LGUs if you provide them with the high resolution flood hazard maps.
Thank you very much, Dr. Tabios. Unfortunately, we're running out of time, but if you check your Q&A, our Q&A box, it's flooded with a lot of questions, and our scientists were very gracious to answer them. So please check them out. But at this point, I'd like to pass on the floor to a gentleman who everybody knows, Engineer Tito Aliga. Tito will be honoring our early donors for this project and the professorial chairs. Tito belongs to the exalted 106-strong engineering class of 1966, whose claim to fame is none of them graduated with honors. I don't know if they're very proud of it or they're just saying it was so tough during their time. So, but many members have done well, and I'm a witness to that. Some of them are senior executives of very big corporations in the Philippines. Graduating BSME, he had a short stint with Steel Foundry, division of EI Corporations, and he did productivity and engineering work with SGV Consulting, where he spent a lot of years. Based in Manila and Jakarta, plus a stint in Lagos, Nigeria, our friend Tito got his MBA from the Wharton School of Business at the University of Pennsylvania under the sponsorship of SGV. After his retirement, I don't know what he calls a retirement, he became active with UP Engineering Research and Development Foundation as a trustee, became its president from 2013 and 2017, and continues to be its executive doer to this day. Most of you must have received his emails, and he makes kulit to you to participate, and that's his special skill. And thank you, Tito, for doing that for all of us to make better engineers in the Philippines and the world. So let me pass on to Tito to acknowledge our donors and to honor them during this web conference.
Okay. Thank you very much, Dante. My internet connection here home is spotty, so if you don't hear me, then please just continue with the program. Can you hear me, Dan?
Yes, very well.
Okay. Yeah. So, ladies and gentlemen of the UP Global community, good morning. It is my distinct honor and privilege to host this 5-minute part of the program, a short, meaningful event, as we acknowledge the donations of 2 distinguished alumni who have just established the latest 3 professorial chairs in the College of Engineering. Both of them, Gus Rahman and Danny Reyes, were earlier introduced in the first part of the program, as they are both early responders to our call for support for the High Performance Computing Project. Their generosity knows no bounds. Gus and wife, Tessie, who was my colleague in GV, sponsored the Lagan family UP Engineers professorial chair. Gus's father, Aurelio, belongs to ME class of 1928. And brother Aurelio Jr. or Toti, I think he is with us, is ME class 53. Toti lives in Las Vegas. Danny and his wife, Huelma, set up 2 chairs one each in honor of his departed parents. His father, Daniel, who is a civil engineer, and for his mother, Lodevina Villagrasia, who is a teacher. Danny and Huelma live in Westlake Village, Southern California. So may I now ask Gus to share with us his thoughts about the joy of sharing his blessings. Gus? Gus, I saw his face a while ago.
Can you hear me now?
Yes, Gus.
Okay. Well, I actually stumbled into this opportunity to make a donation because I had some extra funds, and so what I did was I called my high school alma mater and contacted the UP as well for my college, being my college alma mater, and I didn't know that there was such a foundation, and so Virgil and Tito were the ones who sort of guided me into making this donation to the UP Engineering R&D Foundation. So I'm happy about it. That it's going to be put to good use. Yeah, that's.
Thank you very much, Gus. So Gus is a double donor, one for the high performance computer and for the professorial chair. And now let us listen to Danny, all the way from Westlake, California, who is a Grand Slam donor. I call it Grand Slam because he gave to the Performance Computer Fund and the engineering laptop drive in addition to these professorial chairs. Danny? How is California?
Oh, I don't know. I tried start there. Hello.
Hola.
Oh, okay. I guess I'm unmuted now. Hello.
Yes, please go ahead.
Okay. Yeah, I first got involved in fundraising for PGH one day, one weekend when Joe Albano called me, and PGH was requesting aid for their PPEs. And at the time, you know, that's the first time I heard about it, and having just sold some stock, I pledged a sizable amount. And that was the start of it. And I know Tito from college because we were together for the longest time. We happen to be brothers in the fraternity also. And he's just 1 year ahead of me. And I finished electrical engineering in 1967. Anyway, that was the start of this donations to the University of the Philippines College of Engineering. It started with Joe Albano calling me one weekend and said, "Man, have you heard about this thing about the PPEs being needed by PGH?" And I wasn't aware of it, but why did I just pledge something? And I talked to Marty and, "Okay, Marty, I'm pledging this amount," and he was telling me, "Dan, that's too much. That's too much. Why don't you, you know, scale that down?" And I said, "You know, I really need that as a tax deduction." So, anyway, that was the start of it. And Tito and I were continuously talking and communicating, and he convinced me to start with 2 professorial chairs for my parents, and then. Just lately, you know, the stock market has been going up and up, and I was able to raise some more funds. As I told him, "Hey, why don't we just make this a 5-year plan? You know, I'm going to donate for 5 years this certain amount." And I told him, "You can just allocate it to any program that you want, including the professorial chairs for my parents." And I guess that was really now that's where we're at. And I really want to help. I have been a beneficiary of the best education in engineering from the college, and I want to give back. So anyway, that's about it, I guess.
US based.
Yeah, thank you very much, Dan. Thank you very much to you and Huelma for your generous donation. Now, before I end my slot, let me acknowledge.
Boss Tito,
yes.
We would like to invite I saw his face on the call, Engineer Joe Albano. We want him to say a few words as well.
I guess Joe would like to.
Sir Albano, Sir Joe, can you say a few words, please?
This is Joe Albano. I have a mechanical engineering degree from UP in 1967. I was in the same time in Diliman with Danny, Tito, Aliga, and so on and so forth. Anyway, after participating in the presentations, I was very impressed by the presentations of Doctors Noga, who else, Dr. Fabius, and who was the last one?
Dr. Kinay.
Dr. Kinay. I was particularly interested in the earthquake simulations that Dr. Kinay is doing at the computer lab, because I own a condominium unit in Davao. I won't tell you what the developer is, but we haven't been able to occupy our unit since the earthquake happened. So when I visited Davao in February, I noticed right away that with my little knowledge of earthquake damage in buildings, I continue to work for the San Francisco Fire Department, as well as I was a program manager for seismic retrofit for Pacific Telephone at that time, about maybe 30, 40 years ago. So I have a little bit knowledge of buildings, and I continue to work as a fire protection engineer for the San Francisco Fire Department. So I also deal with a lot of computer simulations, flood ordinances, building ordinances. So I think with this high pressure, high performance computer, we'll be able to improve the building codes and flood control codes. You know, we just the San Mateo County, where the airport is located, they just started enforcing the flood ordinance. So consequently, the buildings at the airport are built higher. I mean, the foundation, the first level are built higher. So I think that's a good application. That would be a good application for this high performance computer. So I'm really convinced that we should support this initiative. And I would like to ask the dean, what is the target date for acquisition of this system? So I also I would like to thank also Tito for introducing me into EarthFi, the Research Foundation. I actually started supporting this foundation 2 years ago, and study grants and all that for students. And then there was a need for the funds for the PPEs. So I'm very happy to see that a lot of the projects have been completed, and some are still finishing up. So I think we should all support this initiative of acquiring this high performance computer. That's all I can say. Thank you.
Thank you very much, Sergio.
Sergio, we wanted to start early, but we would like to recalibrate. I hope we can start it by the second semester in January 2021. Maraming salamat to you, and back to Dante.
Sir Tito, before I pass on the baton to you, I think Sir Vic has something to read from the family of Mr. Herbert Lee.
Okay.
Sir Vic?
Sure. Yes. Thank you, Dante. I just wanted to, Herbert cannot join us. You know, Herbert has been fighting for his life as a COVID patient. He hasn't been able to move since April, and still at the University of California, San Francisco Medical Center undergoing treatment. So, but Marie is very supportive of what Herbert has been doing for the college. And she thought she would write a note in behalf of Herbert for Herbert's contribution. And you know, before this happened to Herbert, Herbert was helping us through his elementary and high school classmate days, the owner of Del Monte, Philippines, who's interested in making a donation. So perhaps Marie will now move on to that point whereby she would approach that honor. But this is what Mrs. Marie Lee wrote. Herbert is an early adopter of technology. In the case of computerization in the College of Engineering, he sees the growth opportunities and feels that this is a good investment in the development of the student body. He believes that this is a good way of giving back to his alma mater, as he benefited from and enjoyed his UP experience. That's the.
Thank you very much, Vic. Boss Tito, you want to wrap up our acknowledgement of our donors?
Yes, Dante, thank you very much. Actually, again, we would like to thank our donors. In fact, I just got a text from Lito Frondoso, our former chairman, that he's donating something big to the high performance computer as well. Thank you very much, Mr. Frondoso, Lito. Thank you. Now, before I leave my slot, let me acknowledge with much thanks our HUPFA colleagues, Vice Chairman Polly Cortez, whom I chatted a while ago, and her associate Julie Hudson, for patiently handling the donations from our US donors. Thank you very much, Polly and Julie. And UP Foundation here in Liman, led by the Executive Director, Dr. Jerry Agulto, and his staff, for completing the flow of funds to UP RDFI. So, salamat, ladies and gentlemen. Thank you very much. We hope to have some of you in our next webinar, either as a high-performance computer, chair, or laptop donor. Sharing your blessings with the College of Engineering. Thank you.
Thank you very much, Boss Tito. To wrap up this event this morning, would like to introduce the president of the UP Engineering Research and Development Foundation Incorporated, Virgil Cruz. He is a proud Tau Alphan, a GP's member, a mechanical engineering graduate in 1986, who started his job as a career as a junior engineer in DCCD, one of the major construction companies in the Philippines, but only for a short time, for 6 months. He pivoted to a marketing and sales career, starting as a management trainee in Unilever, spending 7 years in various brand and sales management roles. He then moved as employee number 1 of the Mayora Group in the Philippines and introduced the now very popular Copico brand in the Philippine market. From confectionery and coffee, he moved to selling beer as VP Sales of San Miguel Brewing Group, and then joined the Ayala land before working overseas in Indonesia as the country manager of Kraft Foods. He came back to the Philippines as president and general manager of Kraft Foods Philippines before rejoining the Ayala Corporation with stints in Globe as consumer business head and most recently as CEO of Manila Water. He retired last year from Ayala after 17 years of service and is now helping a couple of startups and family businesses He is a new fellow of the Institute of Corporate Directors, and like me, Virgil is one of the multitude of recruits of Boss Tito, who now serves in the foundation. Please welcome President Virgil Cruz.
Thank you, Dante. Thank you for the excellent hosting for today. Good morning to the UP community in the Philippines, and good evening to the UP community overseas. We are very humbled by your presence in today's webinar and Zoom fundraiser. We peak at 196 participants today, and it speaks of everyone's strong connection with UP Engineering. On behalf of our foundation chairman, Alex C., our trustees, advisors, and members, maraming salamat po. Thank you to our co-presenters, UP College of Engineering and UP Alumni Engineers. Thank you, UPAE President and Foundation Trustee, General Elmir de la Cruz, for your support. Thank you, Dean Ferdy Manigdeg, for allowing us to use the college facilities for this webinar, for sharing the latest situation in the college, and for clearly framing the need for appropriate tools to equip the faculty, the staff, and the students of the College of Engineering. Thank you to our esteemed presenters today, Professor Emeritus Glenn Tabios, Prof. Errol Kinay, and our computer cluster advocate from the college, Prof. Happy Noga. Really excellent presentations. I realize that giving you only 10 minutes to speak about projects you are so passionate about felt more like punishment than privilege. But thank you for demonstrating what the College of Engineering can contribute to society with high-powered brains compensating for suboptimal computer facility access. We can only imagine what more you can do when high-powered brains is paired with more accessible high-speed computing. You have certainly made a strong case for a dedicated computer cluster for the college. Congratulations. Thank you so much to our early donors, our call to raise 20 million pesos for our high-speed computer cluster facility. Thank you, Joe Albano, Herbert and Marie Lee, Tito Frondoso, Danny Reyes, Gus Lagman. Thank you also to our new professorial chair donors, Danny Reyes and Gus Lagman. Your overflowing generosity really inspires us all. Thank you too to my colleagues in the foundation who made this event happen. Trustee Vic Villagrasia, Trustee and Innovation Com-Chair Chicho Mantaring, our Executive Director and soon Executive Advisor, Tito Aliga, Trustee and VP Dante Briones, and our ever-reliable Nori Ishikawa. As the college accelerates its move towards Education 4.0 and R&D 4.0 with more online and digital tools, the foundation is also moving in step with this direction. We believe digitalizing UP Engineering is a must-do effort for all of us to sustain our collective dreams of building better engineers for the next normal. Internally, in the foundation, we are also stepping back on what we see to redesign internally, what we need to redesign internally to update ourselves in sync with the times while fulfilling our mission of bridging the UP College of Engineering and society for inclusive development. From this pandemic, a new breed of engineers will emerge, toughened by a long-drawn crisis and comfortable with uncertainty while witness to unbelievable generosity and malasakit. With nerves of steel and hearts of gold, they will serve and take care of our future in unprecedented ways. There is hope for the future, and this future will be so much better if you help us build this computer cluster as soon as possible. 20 million in 2020 is doable with every little bit of help from all of you. Stay safe and healthy. Mabuhay po ang UP Engineering, mabuhay ang Universidad ng Pilipinas. Back to you, Dante.
Salamat, Ferds. So again, thank you very much to our presenters. We are forever grateful to our donors Thank you very much to the officers of EarthFE and UP Alumni Engineers and the College of Engineering who continue to connect the dots to make this happen. And to all the participants in today's session here in the Philippines, in the US, and all over the world. Tito and Vic has explained earlier how you can contribute to this project. Please get in touch with us. We have many other projects in the UP Engineering R&D Foundation that might be close to your heart, or you may perhaps want to start a project that you are willing to support. Please let us know. Your donations can come in other forms other than financial. Your time, your network is valuable for us as well. Let us know. You can be part of the UP Engineering Research and Development Foundation and work with like-minded people who are single-minded in helping UP produce the best engineers to serve our beloved UP and our beloved nation. We will see you in parts 2 and 3 of this series on high-performance computing and in the other webinars that the UP Engineering R&D Foundation will be hosting throughout the year. Mabuhay kayong lahat at magandang araw sa inyong lahat. Thank you.